So we saw expected value in a very basic gambling context, and now we want to kind of kick it up a notch to a casino game. And we're going to work with the American roulette wheel yet again, just like we did in Chapter 5. So you're going to bet on a single spin of the American roulette wheel. And the casino payout for a line bet is 5-1. Now, just keep in mind that when you walk up to a casino roulette table, it'll have the payouts listed, or they'll have information somewhere. They always do for every gambling game, so you know what your payouts are. So if you walk up to the board, it'll have all the different kinds of bets. And for a line bet, it says it's 5:1. A line bet being you put your chip here on the edge here, and it's betting on all the 6 numbers in that line. Now, what does that mean? Well, it means that if you lose, you lose your ante. Your ante, A-N-T-E, it's Latin for before. It's the $1 you pay before you play, right? So when you pay in roulette, or you pay in any game, right? So you put your money into the pot for poker, or you put your money into the slot machine, or you go buy your scratch-off ticket, right? When you put that money in to buy the scratch-off ticket, that's your ante. It's the amount you're paying to play. All right, so you have your $1 ante. If you lose, you're out the $1, and it's lost to you, which is negative. In gambling, it's always negative for loss. Now, other things like business, it might not be. It just might mean you're not winning as much, right? So I could take home $1,000 or take home $10,000, right? But for this, because it's gambling, it's going to be negative. And if you win, you're going to win $5. Now, how does that work? Because it says 5:1. What does that mean? It means that you get your $1 back, but that doesn't count as profit because that was your ante. That was what you paid to play. So it's not to your profit. It's just what you put in. The profit is the gain that you get other, right? What you take in from the casino that they weren't going to give you otherwise. And that's the $5 right there. So the 5 is your profit. The -1 is your loss, right? So your gain, or sorry, is your gain, right? Profit is gain and loss. Profit can be positive if you're gaining, can be negative if you're losing. And the amount that you have in your hand after the spin is over is 5 more than what you started with, if that makes sense. Now the chances of winning is 6 out of 38 because there's 6 numbers in this line right here. And there's 38 numbers total, so that means there's 32 losing numbers. All right, so now we're going to find the expected value. To do that, we take the profit, 5, multiply it by the probability, 6 out of 38, and then subtract 1 and multiply it by 32 out of 38. All right, so that is what it is if you do it by hand. So let me just show you. That's the formula. So 5 times 6 divided by 38 minus 1 times 32 over 38. Enter. And there you have it. Of course, we haven't been doing the by hand formula very much, so you could also use stat, edit, put your profit over here, your gain and loss in L1, and then your probabilities, I just typed those, 6 divide 38, enter, and it comes up with it. 32 divided by 38, enter. And it has them. Stat, calculate, one variable. Remember that this section is the one section besides section 3.3 that we use a frequency list. So we get to get our freak on, as it were, right? So our frequency list is L2. The rest of the course, we leave it blank. But section 3.3 and 6.1, which are the weighted means sections, we will actually use the frequency list. So I'll go down to here to calculate. And there you have it. X bar right there is negative 0.0526. All right, so that's our X bar. Whoops. Now we have to ask ourselves, is that a fair game? Well, a fair game was mentioned earlier. A fair game is a zero-sum game. Let me scroll back to the notes real quick. There, it's right here, highlighted in yellow. In gambling or betting, when the expected value is 0 is what makes it a fair game. It's also called a zero-sum game. So I'm asking for our roulette example, is it a fair game? To make it a fair game, it would have to have an expected value of 0. But we don't have an expected value of 0. We have an expected value of negative 0.0526. You expect to lose 5 cents for every time you play this game. which by the way means the house is expecting to gain 5 cents because your loss, negative, is their gain, positive. So that is totally not fair because your expected value is not 0 and their expected value is not 0. Right? So because the expected value of the profit is not 0, that is not a fair game. And actually, I kind of gave away the store over here, so let me just put this in here. The house edge is 0.0526 because for every 5 cents you're losing, the house is winning. A lot of times they'll write house edge as a percentage because they don't want you to think of it as 5 cents. They want you to think as 5.26%. So the house expects to make 5.26% of every bet. Not a lot, right? But that's how much they expect to make on each little bet, and that'll add up if they have thousands of people in their casino. All right, so there we have it. So because when the player loses that 5.26 cents, or sorry, $0.0526, I guess I should say, $0.0526, in other words, 5.26 cents, they're losing it to the house. So the house is gaining what they're losing. So whatever this number is negative, then this number is positive. But they like to write it as a percent because that's what they're expecting to make for every line bet placed in roulette, because that's what this is. This was on a line bet. It's possible some of the other bets in roulette would have different percentages, or some of the other games in the casino will have different percentages. But that's what the house edge is. It's the percentage they expect to take for every gamble made in the casino. I'll just add a little note right there. So the house edge is the percent expected to be made on every bet. Now, just on a side note, a casino is, when you're in a casino, you want to play games that are closer to fair. So you want to play games that are closer to 0 for house edge. None of them are going to actually be 0, but some are going to be closer than others. Like blackjack is pretty close to 0, and craps, if you know what you're doing, can be close to 0. Roulette is not that far away, but it's far enough that you don't really generally want to play roulette. But scratch-off tickets in Michigan, where I live, are 10 times worse than this. A scratch-off ticket has a house edge of easily 50%, right, on average. So you're way better off playing a few games of roulette rather than scratch-off tickets. But of course, you'd have to drive to the casino and actually be there, which means you're probably not going to leave. So you'd lose more money in the long run at casino generally. All right, let's do one last lottery, which is in 1977, the state of Michigan approved the Michigan Daily 3 drawing. This is a game where players across the state buy lottery tickets during the day in which they have selected a 3-digit number. So you select a 3-digit number, and then at 7:30 every night, the state lottery officials select the winning 3-digit number on television. I remember watching this with my grandparents when I was a kid. So any player who bought a ticket that matches the official winning number receives a payoff of $600. So calculate how many different 3-digit numbers there are. Well, that's the multiplication rule of counting that we learned back in chapter 5. The number of digits possible for the first digit is 10, because 1 through 9 and then 0, so 10. The number for the next one is 10, and then the third one is 10. 10 times 10 times 10 is 1,000 different numbers. And that's using the multiplication rule of counting that we learned in chapter 5. So you work for the State Lottery Commission in 1976, so before this was invented, and you want to determine how much to charge to play this game. So we're going to make a probability distribution of the winnings, just the straight winnings, not the profit. So let me type up that table. All right, since these are just the winnings, not the profit, when you win 600, right? And then when you lose, you win nothing. Right? Because again, we don't know how much we're charging to play this game. So when you lose, it's 0. You haven't won anything, so 0. The chances of winning, well, there's 1,000 different numbers, so it's 1 out of 1,000. There'll be one winner. The chances of losing will be 999 out of 1,000, because there's only one winning number and there's 999 losing numbers. All right, so we made the probability distribution. If they wanted a fair game, what should they charge? Well, a fair game would have an expected value of 0. So we need to find the expected value of this game, and that's what we should charge people. So I would grab my calculator, and I could type, 600 times 1 out of 1,000 plus 0 times 999 out of 1,000, which you don't really have to do because 0 times anything is just 0. So that makes 0.6. So the expected value is 0.6. So that's how much you should charge to play if you just want to break even. If the state of Michigan just wants to do this to make its people happy and doesn't want to make a profit to put into the coffers of the state, which of course is not how that works, but that's all right. There we have it. So that's how much the state of Michigan should charge. On a side note, if you don't want to do it by hand like I just did, you could clear out L1, clear out L2, and type it in here. So you'd put 600, you'd put 0, you'd put 1 out of 1,000, and 999 out of 1,000, or 0.999. Then you would do stat, calculate, one variable. We do use the frequency list here because this is a probability distribution, and 0.6 right at the top is our expected value, right? Okay, so suppose the state of Michigan charges $1 to play this game, which actually I think is what they charge. What would the expected profit be? Well, if they charged 60 cents, they were going to break even. So if they charge $1, that's 40 cents more. So that's how much profit they're making for every ticket. And that's what I just typed up, right? They only need to charge 60 cents to make it a fair game. So by charging more than that, they're making it so that they've got more. And you'll notice that is much higher than, like, say, the 0.05 that we just saw for American Roulette. American Roulette was like 5 cents. This is already, just with my little scenario here, at 40 cents. That's a lot more profit for the house, if you will. So that's a 40% house edge. I just typed that up. So by this being 0.40 for the expected profit, that means that the state of Michigan has a 40% house edge. That's very huge in this game. And the player's expected value for a single ticket is negative 0.40. And that's way worse than the line bet in roulette. It's about 8 times worse, 7 to 8 times worse. So, not good. If the state sells 8,000 tickets in this lottery, what's the expected profit to the state? Well, they expect to make 40 cents for each ticket, right? So if it's 40 cents for each ticket, 40 cents for each ticket, we'd multiply that by 8,000. So you take 8,000 times 0.40, and you'll have how much they expect to make, if I can type it correctly. All right, so 8,000 times 0.40. Enter. $3,200. So they expect to make $3,200, the state of Michigan does. Now, $3,200 might seem a lot to you and me, and it is, but it's not enough, right, to run the state. So they have daily 4 drawings and lotto drawings and Powerball drawings and Keno and scratch-off tickets. And all of those things together combined add up to how much gambling the state of Michigan, in my particular state, is having players play.